sir.
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 Okay. Next, I think this is also completed, right? Shorter span.
Yes, sir. Completed, sir.
Okay.
Shorter span, maximum spacing, sir.
Okay. Even maximum spacing is completed, right?
Yes, sir.
Okay.
Yes,
Next. Next, take down. Area of reinforcement for longer direction in the middle strip. Area of reinforcement for longer direction in the middle strip. You have formula, that is m is equal to 0.87 Fi ASTD into 1 minus Fi AST divided by FCKBD. So here mx, what is the value you have to consider? Mx value?
Sir, 15.2.
Hmm?
7.129.
Okay. Take down 7.16 and you have to substitute the values, and as you have seen it is changed. Okay, D is correct now. Okay, so D is
Sir,
120.
7.12, sir.
Okay, okay.
7.12, sir.
Oh, okay, how much answer you are getting? Okay, 7.12.
Sir, for longer span, we want to take my na, sir.
Which one?
mx, my ತಗೋಬೇಕಲ್ವಾ ಸರ್?
ಹೌದು, ಕರೆಕ್ಟ್ ತಗೊಂಡಿದೀವಲ್ಲ.
ಬಟ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ mx ಅಂತ ಇದೆ ಸರ್.
ಸಾರಿ. Yes. My value. And even this is ASY. Okay, AST y,
Okay, sir.
and this is dy. Depth will be same on either side. Okay, it won't change. And even this is also SY. So how much answer are you getting? Are you getting 140?
Yes, sir. 140.51.
Okay. So here it is changed. That's why here it is minus change. Okay. You're getting 140. Okay. Anyhow, you have to compare this ASTY with AST minimum, right? You know the value of AST minimum which you have already calculated. It is 180. So which one you have to consider?
AST minimum, sir.
Okay, take down, because ASTY is less than AST minimum. Provide minimum reinforcement of 180 mm square. Okay, finished. Next.
Yes, sir.
Next, take down spacing of 10 mm dia bar Spacing of 10 mm dia bar, small AST by capital AST into 1000. So calculate the spacing.
Four 436.33.
Okay. So next, take down. Maximum spacing is the least of the following. Maximum spacing is the least of the following. That is 3D 300 and the spacing which you have calculated. So among these three, you have to take the least. Okay, take down. Therefore, provide 10 mm dia at 300 mm center to center. Finished? Okay.
Yes, sir.
Okay. Next, take down. Area of reinforcement for longer direction at continuous edge. So earlier it was mid span. So now we are going to calculate for the continuous edge. Okay. Take down the formula, that is m is equal to 0.87 FIASTD into 1 minus FIAST divided by SCKB BD. So here, what is the value you are going to consider?
$9.57.
Right. So to consider 9 point. So what was the value actually? 9 point. Khalid?
9.57, sir.
Okay, okay. 9
5
point.
sir.
Okay, 5.6 or 5.7. Okay. So remaining values, you know, you substitute and calculate ESTY. And after this, you have to compare with the EST minimum. Actually, procedure is lengthy, but it is easy, isn't it?
Yes.
So how much you are getting? ESTY?
One 190.92.
190.2.
190.92.
Okay. So you're getting 190.92. So what about others? Are you getting the answer? 190.92. Okay. So after this, you have to compare with EST minimum. So what is the value of EST minimum? 180, right? Okay. So
Yes, minimum.
ASTY is greater than EST minimum. So which value you have to consider now in this case?
AST, sir.
Yes, AST you have to consider. Okay. Now calculate the spacing. Spacing of 10 mm dia bar is equal to small AST by capital AST into 1000. So this is 190. Just check it out, how much you'll get.
Four 411.37, sir.
Okay, 411. So now what you have to do? What is the next step?
Maximal spacing.
Take down maximum spacing. Maximum spacing is the least of the following. So that is 3D and 300 mm and the spacing which I have calculated. Okay. So the minimum is 300 you have to consider. Therefore, take down, provide 10 mm dia at 300 mm center to center. Finished?
Yes, sir.
Okay. Next, take down area of reinforcement. Area of reinforcement in edge strip. Area of reinforcement in edge strip. So here you have to consider the AST minimum. Okay. So AST minimum is equal to 12% BD. So which you already calculated, it is 180 mm, right? Take down this.
Yes.
Okay, finished?
Yes.
Okay, next take down spacing of. So here this is your minimum EST when you are considering. No need to take 10 mm. You can consider 8 mm. Okay, take down spacing of 8 mm dia bar is equal to small AST by capital AST into 1000. So how much spacing you are getting?
Two 279.25.
Okay, 279.25 mm. Okay, so now take down maximum spacing is the least of the following. Maximum spacing is the least of the following. So here you are going for the distribution reinforcement, right? So that is why here it is 5D. Okay, then it is not 300 actually. How much it is? 450, right? Isn't it?
450.
Okay, 5D. Then second one is 450, and third one is the spacing which you have calculated. Okay, among these three, you have to take the least. Therefore, take down. Therefore, provide 8 mm at 270 center to center. Here it is 279. You are just round up into 270. Even you can round up to 250. Not an issue. Okay. So is there any doubt till here?
No, sir.
Next, take down torsional reinforcement at corners. Torsional reinforcement at corners. So this is as per the codal provision. Okay. So area of reinforcement in each layer of 4 layers at corners for an area of Lx by 5 into Lx by 5. Okay. When you consider the slab like this, okay, at corners, so you are going to provide the torsional reinforcement, okay, on all the 4 sides. Okay, the distance is Lx by 5, and even here also it is Lx by 5. We're going to provide on all the 4 sides like this. Understood?
Yes, sir.
Okay. Take down. So Lx by 5 into Lx by 5. Okay, so which is equal to 3 by 4th of the area of steel. So as you know, it is not 211, it is 212, right? Which you have calculated
Yes,
earlier.
sir. Yes, sir.
Okay, it is 212. So calculate 3 by 4 into 212. How much you are getting?
Point.
Okay, 159 you are getting. All are getting the answer?
Yes, sir.
Okay. So now you calculate the
Yes.
spacing. Take down. Spacing of 8 mm dia bar is equal to small ast by capital AST into 1000. So how much you are getting?
Sir, 316.1.
316.1, sir.
Okay, 316. So as per the codal provision, you have to consider the least, right? So the least will be 300 mm. Okay, take down. Therefore, provide 8 mm dia at 300 mm center to center in 2 perpendicular directions at top and 2 perpendicular directions at bottom corners. Okay. Finish.
Yes, sir.
Sir,
So you have calculated till now what you have calculated? We calculated the reinforcement. Okay, for a longer span and shorter span. Then you have calculated the torsional reinforcement. Okay. Then you have to check for what? Deflection, right? So
Yes,
the
sir.
slab will undergo deflection. So you have to calculate, isn't it? Take down. Check for deflection. Check for deflection. So it is L by D provided is less than or equal to L by D permissible, which is equal to alpha into KT into KC into KF. So how much value you are going to consider for alpha? Alpha value?
$20, sir.
Good. Yes, right. 20. Okay. So you have AST value which you already calculated. Okay. So AST required, that is 258.27, right? Earlier you have calculated. $258 or 212? 212, right? Sorry. So this is 212. Okay. AST required, it is 212. Okay. So next, take down AST provided is equal to. So what is this 300? So this is dia you are assuming for the main reinforcement. So what is this 300?
Maximum spacing.
Okay, this is the maximum spacing. So how much you are rating? AST provided. How much?
261.79, sir.
1.79.
Okay. So it is 261.79. Consider 261.8. Okay. So now calculate the percentage of steel. So percentage of steel is equal to 100 ESD by BD. Again here D you have to consider 120. Okay, sorry, it is 120. It is not 130. So what is the answer you are getting?
Point 2181.
Okay, it is 0.21. So you have percentage of steel now. Now you have to calculate the FS value, right? To refer the figure 4 from IS 456. So calculate the FS value.
Sir,
And
FY 500, sir.
much?
Yes.
Sorry, FI is 500, right? FI is 500.
And 258, sir. 212.
Yes, this is
34.4.
211. Sorry, 212, right? This one is 212.
Yes, sir.
Yes, sir.
Then what about this one? 261.8.
So 234.
So you'll get 230.
234. 234.84.
Okay, 234.84. Okay.
Yes, sir.
Next, take down modification factor you have to calculate. Correct? As per the IS 456 2000, page number 38, figure number 4, you have to calculate the KT value. So for the percentage of steel 0.21, 212, right?
2-1.
So what is the answer? KT value? You'll get around 1.6. You can just check it out.
Yes, sir. 1.5.
Okay, so around 1.65 or 68. Okay, this is an approximation, right? You can consider, but it should be nearer to that. Okay, any doubt in this?
No, sir.
Okay, next, take down L by D provided. L by D provided is equal to the span by the depth. Span is how much? Span is 4120, right? Effective span.
Yes, sir.
Okay. So span is 4120 and D is 120. So how much you are getting?
34.33.
30?
34.33.
Yes, sir.
34 you are getting.
Yes, sir.
Yes, sir.
Okay. If you take 3620 or 30.
No, yeah.
41.
Yeah, actually it is 4120. Span is yes.
14. 41.
34.33, yes, sir.
34.33.
34 you are getting. 34, right?
Yes, sir. 34. Yes, sir.
Yes, sir.
Okay. So we have to check now for L by D permissible. Okay. So check for L by D permissible. How much you are getting?
33.6, sir.
How much?
33.6.
33.6.
Yes, sir.
Yes, sir.
So, but according to this, the deflection is safe or not?
Safe, sir.
No, sir.
Huh?
Unsafe, sir.
Yes, right. So the deflection is unsafe. So what you have to do now?
We have to redesign it.
But you won't get the time.